Okay, good morning class. Right, so today I will give you a link. Okay, so as usual, okay, you have to log in and enter the code, okay, using the link. Okay, so the link is the code is 78251. Okay, so I send you the link again. Okay, so 78251. You can who's still not here?
Two more, Krisha and Lakshmi.
Risha and Lakshmi.
Yeah.
Okay. Risha, okay, my Wi-Fi making problem. Hmm. Okay, so we wait for 3 more. Oh, okay. So, mm, apa? Right, Raja will not join because we need to cut the. Okay, so mean minus Raja will become 15. Seven, 8, 2, 5, 1.
So teacher Izati is not joining us.
Yeah, it's actually not joining because you need to cut the gelang ke
Okay.
because it's close contact, right? He's still not here. Krisha is still not joining, is it?
She's not in the meet yet.
Oh,
6, 7, 8, 9, 10, 11, 12.
so it should be 15, right?
Asher haven't joined.
Asha, are you okay, Asha? Can I give you the link again? Okay, Krisha. 78251. Okay, Vietnam. Okay. So please join. So we should have 15 today minus Izati. So here Krisha and Lakshmi, I think still not joining. Okay, maybe you didn't get the link. I forward again. Krisha, are you okay? Alright. Okay, so we continue. I think we stop until here, right? Okay, this one I didn't discuss yet, right?
Yes.
Okay, so I want you to try to answer. So this is actually involving the resonance, okay, resonant concept. So what happened? How can the glass, okay, break like that? Okay, so try to answer first. They say this is the 4 marks question, okay, that you have to explain. Okay, how does the glass break? Okay, so by using the concept of resonance, okay, so you have to know what is actually a resonance. Okay, it involving the frequency. Okay, I give you a clue. Must have the word frequency. Okay, someone already give the answer. Okay, Eugene, very good. Okay, it says watch a video from YouTube about breaking glass, okay, with high pitch sound as shown in diagram 1.16. Okay, so so natural frequency, right? So must have the word natural frequency. So I give like 1 more minutes, okay? Then I will close. Okay, I will close the teacher. If I want to change answer, cannot. When you already submit, you cannot change the answer. Okay, Asher, where's your answer? Asher, okay. All right, so let's discuss the answer. So what is actually happened? Okay, how does the glass break? Okay, so first one it says the high pitch. Okay, so the high pitch of sound, okay, causes the glass to start vibrating. Okay, so when it vibrate with the same natural frequency of the glass, okay, so the glass will be break, right? Because it reached this because the sound frequency of the sound, okay, is same as the natural frequency of the glass. So every object they have their own natural frequency. So let's say if you can give, say if you sing, okay, and then the frequency is actually same as the natural frequency of the object will start vibrate. Okay, so when it reach the maximum amplitude, it will break. Okay, so here the glass vibrate as at a maximum amplitude until it breaks. Okay, so this is your answer. So when the frequency have the same force, frequency of force, um, because this one is sound, right? Frequency of sound, okay, is much better. Okay, have the same frequency as the natural frequency in the cup. Okay, right. The resonant frequency is too high. The air particle will vibrate. The vibrate they vibrate too much that glass shatters. Okay. So for this one, you have to say the natural frequency, right? The sound frequency, the frequency of the sound is same as the natural frequency of the glass. Okay, then it will start vibrate. Okay, then it will vibrate with the maximum amplitude and the glass will break. Okay, so for this one, from 4 marks. Okay, so this one I will give like 4 marks. So for this one, I will give 1 mark. This one mark. This is wrong. The vibration from the high pitch have forced the glass to the high frequency. The energy is transferred. No. Okay, because you have to say the same. The resonance happens when the frequency of the sound is same as the natural frequency of the object. Then it will start vibrate. Both of the glass have the same frequency, so the frequency water is in resonance with the frequency. Okay, so for this one I will give 2 marks. The high frequency, no. Frequency increase, no. Okay, so the resonant frequency is same as with the high pitch. The resonant frequency is same with the high pitch. It's not pitch, it's actually same as the frequency of sound. Alright, so this is wrong. This is wrong. The glass has censored the frequency. Okay, 1 mark. No. When frequency is very high, we vibrate with the maximum amplitude. No. Being amplified. Natural frequency being amplified, this causes the no. Because they have the same frequency, not higher. It has to be same frequency as the sound frequency. As the sound frequency and natural frequency must be same, then it will be happen the resonance, not higher. Okay. No. Okay, so let's see how actually you want to answer for this question. So you have to say, okay, the sound frequency, right, has same frequency as the glass. All right, that is, we call it as a natural frequency. Okay, the glass will start to vibrate. In maximum amplitude. Okay, this will cause the glass to break. Okay, so that's the answer. Okay, so you have to say the sound frequency that being produced is same as the natural frequency of the glass. Okay, and the glass will vibrate with the maximum amplitude. Okay, then after that the glass will break. Okay, so that's the answer. Okay, so this is the video. Okay. So they try to sway the bridge. Okay. So they produce the sound. Okay. They produce the sound. Okay, and the sound produced is same as the natural frequency of the bridge. Right. So the bridge will start to vibrate. Okay, with the maximum amplitude. Okay, so you can see here. So the roadway breaks up because of it vibrate with the maximum amplitude. Okay, so you can see it start to vibrate. So then after that, after some time, okay, the bridge will collapse. Right, so this is actually the example of the resonance. Okay, so that's why that's why the army, right, they will not do the marching, okay, on the bridge. Okay, because they say if they are marching and the frequency, okay, is same as the bridge, okay, the bridge will collapse, right? So that's another example. Okay, now for this one. So it says on 7 November 1940, the movement of the wind, they produced the Tacoma Narrow Bridge was in Washington. Okay, so the bridge collapsed as shown in diagram 1.17. So can you explain why the bridge collapsed? Okay, it's just same as the glass just now. Okay, just change the few words. Okay, just same that the one that I give you the answer just now. You just change a few words. Okay, Sharanya, Abi, Tava, Nirupa, Eugene, Lakshmi. Okay, Lakshmi. Lakshmi, are you here? Okay. Alright, so explain why the bridge collapsed. Okay, so means is the first thing you have to say that the frequency of the wind, right? So the frequency of the wind, okay, is same as the natural frequency of the bridge. Okay, so this will cause the bridge to vibrate in maximum, okay, in maximum amplitude. Okay, and number 3, the bridge will collapse. Okay, so that's the answer. So let's check yours. Okay, the vibration from the wind causes the bridge to collapse with the same natural frequency. The vibration from the wind. Okay, give you 1 mark. Because it was the same frequency as the bridge, therefore it was at maximum amplitude. Okay. It's better for you to say natural frequency as the natural frequency of the bridge, because for the resonance, okay, the frequency of the wind must be same as the natural frequency of the object. Okay, this one I give you 2 marks. The wind has the same frequency. Okay. Okay, but this one later mention. Let's say you put here in the bracket natural frequency. Must mention the word natural frequency. So this one I can give 4. Okay, very good, Krisha. Okay, very good, Asha. Okay. Venus respond to increase matches with the Increase amplitude. It's not increase, it's actually at maximum amplitude. Okay, so maybe I give like 1 mark. It has a natural frequency. It doesn't have natural frequency. Oh, actually, all object has natural frequency. But you have to say that the frequency of the wind have to be same with the natural frequency. Okay, so this one mark. The which oscillate is the resonant at very high amplitude. Alright, 1 mark, 1 mark. Okay, very good. I give 4 marks. A strong wind frequency. Okay, this one 2 marks because no mention of the maximum amplitude. Eugene got high the amplitude. No. When the wind drive the okay, this one 1 mark. You didn't mention about the maximum amplitude. The wind produce it's not higher, it's actually same. Okay, it's not higher, it's actually same. Remember the bottom pendulum, right? Okay, when you swing, okay, the one that have the same length, okay, the two of it that have the same length will oscillate in maximum amplitude, right? So it's actually because it has the same length, not the one has the higher or what. Okay, must be same, not higher. Okay, 2 marks, 1 mark. Same natural frequency. Okay, you didn't mention about the maximum amplitude, so only 1 mark. Okay, so we move on to the next one. Okay, so there are 4 actually phenomenon of wave. So the first one we already learned. No, we didn't learn. This is the first one. Okay, so the first one is the reflection of wave. The second one is the refraction of wave. The third one is the diffraction of wave, and the last one is the interference. Okay, so we look the first one, the reflection of wave. All right, so
what can you see at the surface of the water?
So this is the moon. Okay, let's say you go to the beach. Okay, at the night time you can see the reflection of the moon. Okay, at the sea water.
What happens to waves when they are reflected? When you let out a shout in a canyon, what do you hear? Echoes can be heard. How are echoes produced?
Okay, so this one all by the reflection. Okay, by the reflection of wave.
What can you see at the surface of the water?
Okay, so observe the diagram below. What will happen to seawater wave as it hits the stone? Okay, so you can see the seawater will be reflected back, right? So the reflection of wave occurs when an incident wave strike a hard surface and reflected. So the surface act as a reflector, right? So let's say there is a water wave, okay, and then it strike with any hard surface, then it will be reflected back. So the hard surface we call it as a reflector. Okay, so the next part is explain how does the dark and light fringe are formed on the screen. Okay, so if you see in the video, right, it's in the at the waterway, there is a bright fringes, dark fringes. Okay, so how does the bright fringes and also dark fringes, okay, produce? Okay, so let's say the light rays, okay, the light rays, okay, it come from the let's say this is the ripple type, okay, and it pass through the crest. So this we call it as a crest. Okay, so the crest is shaped like the convex. Okay, it's act like as a convex lens. So the characteristic of the convex lens, okay, this is a convex. So the characteristic of the convex lens, they will converge. Okay, they will converge all the light ray to one point. So when they converge all the light ray to one point, they will produce the bright fringes. Okay, they will produce the bright fringes because they focus all the light ray to one point. So they will produce the bright fringes. All right, while at the throw here, okay, so you can see this one act like a concave lens. Okay, concave lens is like this. Okay, so this is like a concave lens. So for the concave lens, the characteristic of the concave lens, it diverge, it spread the light. Okay, it diverge the light. So all the light is not focused at one point. Okay, so they diverge the light. So that's why, okay, at the crest you will see there is a dark fringes there. Okay, so that's the explanation why you can see there is a bright fringes and dark fringes. Okay, when we using a ripple tank, so later if we have a video and I will let you see, okay, actually they will produce the bright fringes and dark fringes. So wherever you see the bright fringes, that one is actually at the crest part, okay, and then the dark one is actually from the throat. Okay, so here is the explanation. So the shape of the crest act as a convex lens. So the crest or converge the light ray to form the bright line. So you can see all the light line, okay, is focused at one point. Right, and then the shape of throw act as a concave lens. Okay, so the throw diverge the light ray to form the dark line. Okay, so this is why you can see there is a bright fringes and also the dark fringes. Okay, the next part is state the law of reflection. So the law of reflection, the angle of incidence is actually equals to the angle of reflection. Alright, so we see the diagram here. Okay, here we call it as a incident wave. Okay, this is the incident wave. Okay, and this is the normal line. Okay, the dotted line is actually the normal line, and the normal line should be 90 degrees from the surface. Okay, it should be 90 degrees. So I already draw here. Okay, should be 90 degrees from the surface. Okay, so whenever you draw the normal line, make sure the line you draw, the normal line you draw must be 90 degrees from the surface. So let's say if the surface is like this, okay, let's say the surface is like this, then the normal line should be like this. Okay, yeah, the normal line should be like this, should be 90 degrees from the surface. All right, so here is the incident wave, here is the normal line. All right, this is the reflected wave. Okay, and I is the incident angle. Okay, I is the incident angle and R is the reflection angle or angle of reflection. Okay, so from this, from the law of reflection, okay, we know that the angle of incident is equals to angle of reflection. So means I is equals to R. So let's say my I is 50 degrees. Okay, so my I is 50 degrees. So means for R also should be 50 degrees. Okay, so that is the law of reflection. The I must be same as R. Okay, and then remember the normal line should be 90 degrees, okay, from the surface. Okay, so this is the experiment. Okay, so later if we have a chance, we will do this experiment, okay, at school. All right. Okay, so remember just now when I said about the bright fringes and dark fringes. Okay, so this is the bright fringes. So at this part, this is the crest part. Okay, while the dark one is actually the throat. Okay, so why? Because the crest is actually like act like as a convex lens. So means all the light ray will be converged into one point. So means that's why it produced the bright one. Okay, so let's see what will happen. Okay. Wait, Okay, so you can see here the wave, okay, the water wave come from the right to the left, right? Okay, in this direction. Okay, come from this direction. Then when it hit the surface, okay, it will be reflected. Okay, okay, it will change the direction. It will go up like that. Okay, so this is the example of the reflection of water wave. Okay, so you can see the water wave travel from the right to left. Okay, and then after they hit the reflector, it will go up like that. Okay, so this is the example of the reflection. Okay, so the next part, how you want to draw a straight line to present the direction of the propagation of the incident wave. Okay, the first thing you have to draw the incident ray first. Okay, you have to draw the incident ray first. Okay, and then after that, so I explain to you how to draw. Okay, so let's say this is the plane, this is the reflector, right? And this is the incident wave. Okay, draw an arrow. Okay, and then you draw a wavelength on the top of the incident wave. Okay, and make sure the wavelength is same. Okay, the wavelength is same and is 90 degrees from the direction of the incident wave. Okay, it must be 90 degrees. Okay, after that, all right, you draw the normal line. Remember I said just now the normal line must be 90 degrees from the surface, so it should be like this. Hey teacher, is it okay if I didn't use a dotted line, I use a straight line like this? Yes, also can. Doesn't matter as long it's a normal line, it must be 90 degrees. Okay, so after that, okay, this is the angle, right? This is the incident wave, and you know based from the law of reflection, I is equals to R. So this one is the I, incident angle. Okay, so you can use a protector or you can just estimate. All right, you just estimate. So let's say I just draw like this. Okay, so this is the reflected wave. Okay, and this is my R. So you can see my I and R is almost the same. But if you want that to make it more accurate, okay, you can use the protector. You measure, let's say I is 20, then R also you draw 20 degrees also. Okay, and then after that you draw the wavelength. So the wavelength must be same. Okay, before and after, because that is the characteristic of the reflected wave. Okay, so for the reflected wave, okay, the speed, okay, the frequency, and also the wavelength is same before and after reflection. Okay, the wavelength, the speed, and the frequency is same before and after reflection, right? But the only thing change is the direction of propagation. Okay, change, because you can see the direction, okay, is changed, right? Before this is go down like this, when it strike the reflector it go up, so the direction is changed, and also the velocity. Why? Because the velocity is a vector, so it needs to have a direction. So here you can see the direction is same, even the magnitude is same, but the direction is changing, so means the velocity is not same for the reflection of wave. All right, so this is the characteristic that you need to remember. This one is very important. Okay, usually they will ask question about this one. Okay, all right, so can you understand how to draw for the reflected wave? Anything you want to ask?
No, sure.
Anything? Everyone clear, is it?
Clear, teacher.
Okay, thank you. Alright, so this one I already, okay, so for this one you have to draw on your own. Okay, can join the class point app again because I accidentally deleted. Sure, how to draw a perfect line to this on the slide. Um, Sorry to say there's no way unless you're using the board, drawing board, yes, or maybe you use the touchscreen laptop or using a tab, yes. Okay, Rindia, you cannot enter again. Yeah, you can join, but you can tell me the name. I will delete here. So I delete your name here, okay? You can enter again. It's okay as long as I can see the wavelength like is almost the same because I know it's hard for you to draw like exactly like the incident wave, right?
Teacher, mine looks something similar. I think you can find it.
Something similar. Okay, we wait for others to submit. Maybe I think now you are very struggling to draw with your mouse. Make sure have normal line. That's the important part. The normal line. And also I want to see maybe the angle, okay, maybe cannot get like maybe it's almost the same. Okay, but let's see.
Teacher, I forget to label the normal line.
But you put the dotted or not, the dotted line or not, or you just draw
No,
the.
but I use different colors.
I use different colors. Okay, but I mean you draw the normal line, but you just don't label it. Is it?
Yes.
Okay, it's okay. Because I noticed some of you in this class they are perfectionists. They want to be when you draw very neat one. Okay, it's okay because this one you cannot get a very straight line because unless you're using the board or using a ruler. Okay, I give like maybe 2 more minutes.
Teacher, mine keeps lagging. I cannot draw properly. Can't draw at all. It keeps lagging. It doesn't let me erase. It lets me.
Teacher, I can draw on my phone. All right. Okay. What to do? Taking time to upload. Okay, never mind. I'm very patient. I can draw. Okay. what phone you use, Taba? Okay. Samsung. I think. Okay, we wait for Janet. You already submit or not?
Haven't.
Okay, I give you 1 more minute, then we stop and we see your drawing. Okay, but I will show mine first. Yes, Avinash. I can't seem to submit. Maybe because you just joined, is it? Okay, sometimes you can submit because of the line. Okay, if you have a line problem or maybe that time the line slow. Okay, so I will just stop here. So we see what we have. Wow, it's quite nice actually. Okay, never mind. Okay, so this is actually how to draw.
Teacher,
Yeah.
I got scared when you put a straight line which was straight because
Straight line request. But this one, yeah, they use pen, so it's easy for it to draw the straight line. Okay, then after that, you just draw the wavelength. Okay, so this one, let me see your answer first. Okay, I will. This one is actually you need to draw the normal line. Okay, if there's no normal line, you cannot get a mark. Okay, there must be the normal line is a compulsory. Okay, you must have the normal line. Okay, and this one, okay, I don't know, maybe because it's hard for you to draw using a mouse, but this one, the wavelength should be same, okay, before and after. So you just estimate or you can just measure and you draw here. Okay, Nirupa. Okay, for this one, they say this is 2 marks. I will give you like 1 mark. Okay, but I assume you know the wavelength must be same. But let's say in the exam, you draw like this, you get 0 because the wavelength is different. Okay, very good, Trisha. Okay, very good, Abi. Okay, this one is only 1 mark because no normal line. Wow. Okay, 2 marks. Okay, good, Kritika. Mention I is equals to R. Good, we can. Sajiv, are you saying that I is equals to R here? Yes, okay, right. But this one, if you draw using on the paper, okay, I will give wrong because the angle is not same. But this one, maybe I understand you draw by using a mouse, so it's acceptable. Okay, so 2 marks. Why should be like this? What does it mean by this one? Are you saying that this one is 90 degrees or what? Okay, 90 degrees is from here. Okay, here is 90 degrees. Okay. All right. This is normal line, or you put the dot like that. Okay, you just can put the straight line. All right. So I think it's okay. You can understand. Okay, how to draw the reflected wave. Okay, so let's see for this one. That one is the, let's say the reflector is in the straight line like that. So what if like this? Okay, how you want to draw? Okay, so for here it said you have to draw the diagram to show a reflection of wave. So here we already know the wavelength and also the speed is same. Okay, and the I must be equals to R. So here when this is the incident wave, okay, the black one, okay, incident wave, then when it hit the reflector, it will be reflected back. So the blue line here shows the direction of the propagation. Okay, is shows the refracted, okay, reflection wave, okay. So this is the line showing the reflection of wave, okay, and another one it shows the direction of the propagation. All right, so you can see the the black one. All right, the black one, the distance, okay, the distance of the wavelength for the black color and also with the red color one, okay, they are same. Means after the reflection, okay, the wavelength is same. The blue one is the incident wave, the red one is the reflected wave. So you can see the wavelength is same for both wavelength. And for this one, you see here this is the incident wave, okay. Then when it hit the reflector, okay, so you draw the line first, okay, and then so I show you this one. So let's say if I have a reflector like this, okay, so this is the incident wave, okay. Then I draw the 90 degrees, okay, the normal line. Okay, this is the reflected wave. Remember, I must be equals than R. So this is I, then this is R. Okay, then after that I draw. Okay, I draw the wavelength. The wavelength must be 90 degrees with the direction of the propagation. Okay, so and then after that for this one should be like this. Okay, right. So that is the how you want to draw, okay, the wavelength if it hits the reflector, okay, that be okay arranged like this. All right, we move on to the next one. So it says here you have to compare the angle. So again, we already know by law of reflection, the angle of I must be same with R. Okay, and then how about the wavelength? The wavelength also must be same. Lambda 1 is equals to lambda 2. Okay, so means lambda 1 is a before it being reflect. Okay, and after it being reflect, lambda 2. Okay, both must have the same wavelength. Okay, so here we have to compare. Okay, compare the incident wave and the reflected wave in terms of speed. So the speed is unchanged, all right. The wavelength also unchanged. The frequency also unchanged. The only thing that changed is the direction, and another one is velocity. Because the velocity they need the direction, and you can see the direction is changing. So means the velocity also will change. Okay, but the magnitude is same. So speed is same. All right.
Imagine, right, to expand some, especially for beaches that
Okay. I just show a few videos.
Hi, I'm Elaine. See, just like when you are at the beach and you go walking right by that ocean where the scientists are sure, please, that wave energy. Hi,
So this one is actually to show the correlation.
Naturally, what do you see happening? What do you see? What do you notice? What things? What do you see
Okay.
happening
This is actually the effect of the reflection of wave.
every
Okay.
day? On 6.
Okay, so this is actually the effect of the reflection of wave. Okay. Can cause the corrosions. Okay. Alright, so the next part is to study the application of reflection of wave in daily life, right? So name the reflected sound wave. Okay, so just now we see for the water wave. Okay, for the water wave. Now we see for the sound. Okay, for the light, I think you already learned in science form 2 or form 2, I think. Okay, that one you already learned. Okay, so for this one is only for the form 4, you only learn for sound and also water wave. So what the name the reflected sound wave? So the name of it, we call it as a echo. So list 3 types of sound wave with the range of frequency. So the first part is the infrasonic sound. Okay, this one is less than 20 hertz. Okay, And normal audio sound is 20 hertz to 20,000 hertz. So this one is the range of human can hear. Okay, so they can hear only 20 hertz until 20,000 hertz. Okay, for the ultrasonic, more than 20,000 hertz. Okay, so usually we use the ultrasonic. Okay, mostly the thing that we use is ultrasonic, such as if you want to find the depth of the water, okay, for the submarine, so they need to know how far that they already in the water, okay, how far they already go inside the water, so they will use the ultrasonic. Okay, so later we will see how they use it. Okay, and also the bat also use the ultrasonic wave, okay, to know whether it's obstacle, okay, in front of it, or maybe there's a food, okay, maybe there's another animal, okay, so they use the ultrasonic sound also. All right. So this is an example of echo. Okay, so this is example of echo. Okay, this is inside the tunnel. Okay, so this is another example of echo. All right, so let's move on to the next part. Okay, so a diagram shows a sonar system. Okay, so a sonar system is used to determine the depth of the seabed. Okay, the depth of the seabed. So a sonar system has a very high frequency. Okay, what does it mean by sonar? Sonar is actually a reflected ultrasonic wave. So mostly that we use in our daily life, okay, is ultrasonic wave. Okay, so the ultrasonic wave, this is the ship, okay. So this is the ship. They have the transmitter there that we transmit the ultrasonic wave, okay, to the seabed. And then after it hit the seabed, of course, there will be a reflection, right? So it will be reflected back. So the ultrasonic wave will be reflected back, and then it will reach the receiver here. Okay, so then how they know what is the depth of the water here? So they use this formula, V is equals to 2S over T. Okay, so they already know the velocity of the ultrasonic wave. Okay, so they already know the velocity of the ultrasonic wave. Okay, when they transmit, they already know the velocity. Okay, and then they take the time only. So what is the time taken? Okay, starting from it transmit the ultrasonic wave, then it received by the receiver here. Okay, so how long does it take? So that is the time. Okay, and what you need to find, this one is actually the S here. Okay, why it divide by 2? Because you can see there is this is S and this is also S, right? So you need to find only one S. So that's why later you have to divide by 2. Okay, or you can use this formula. There are two actually, there is same. Okay, for this one you just straight away use it, and this one you need to move it, okay, and find S. All right, so it depends on you which one you want to use. Okay, so that is how does the ultrasonic wave is used to measure the depth. Okay, and sometimes for fishermen, okay, this one is like a big ship. For the big ship, okay, so how they can know whether there's a fish, okay, there's a fish under the water. So they use the ultrasonic wave to detect. Okay, so let's say there's a fish, okay, below the ship. So they will transmit the ultrasonic wave. Then it will hit the fish, right? Then it will be reflected back. So when it reflected back, they know that actually there's a fish. Okay, so there they can catch the fish there. All right. So that's also, but that one is actually the technology used for the big ship. For the smaller one, no, they didn't use like that. Okay. So this is the sonar. What does it mean by sonar? So sonar is the reflected sonic wave. It's to navigate, communicate, or detect object under the surface of the water. Okay, so state the sound wave phenomena to measure the depth of the sea. So this one they use a reflection. Okay, there must be a transmitter that will transmit the ultrasonic. Then after they hit the seabed will reflect back the ultrasonic wave. Okay, and then it will reach the transmitter. So based on the transmitter, they can detect, okay, what is the time taken, okay, to reach the transmitter. Then you just use the formula, then they can know how far, okay, how far does the seabed, okay, from the ship. Alright, so explain why sonar use a high frequency sound. So usually high frequency sound, they have high energy. So mean if they have high energy, they can travel further. Alright, they can travel further. So this is actually the example, okay, for 4 marks question, alright, how the explanation part, right? So explain how to measure the depth of the seabed. So the first one, you have to say the transmitter that emit the ultrasonic wave, okay, the one that I explained just now. The transmitter have to emit the ultrasonic wave, okay, and then it will be reflected by the seabed, okay, and it goes to the receiver. Okay, and then the time interval, okay, is being recorded, okay, from the time it being transmit and it be received by the receiver, okay, and then by using the formula, you have to state the formula, all right, and then you can get the marks. Okay, so this is the 4 points that you need to state. So remember, you have to need to put the equation here, and you have to define for each type of the symbol here. So what is S? S is the depth of the seabed. What is V? V is the velocity or speed of the ultrasonic wave. Okay, what is the T? T is the time interval, okay, between the time they transmit the ultrasonic wave until it receive, okay, by its receiver. Okay, and then another one, so 2 no need lah. You already defined this symbol, okay. So whatever you want to answer, if you use a symbol, you have to define it. Right? Okay, so this is the example how you want to calculate the depth of the seabed. So here they already give you the time. So the time is 0.28. So the speed is 1,500. So you just straight away using this formula, S is equals to VT divided by 2. So the speed is 1,500. The time is 0.28, then you just multiply and divide by 2, you will get 210 meter. Okay, so that's the depth of the seabed. Okay, for F, you have to explain why the speed of sound in water is high, okay, than the speed of sound in air. So this one, I think we already know that sound, they need an air molecule, right? They need a molecule, they need a medium to be transferred. So if you put in the vacuum for sound, you cannot hear the sound. Okay, so they need the air molecule. So the difference here is because the arrangement of the molecule. So arrangement of the water, of molecule in water, they are much closer than the air. Okay, so let's say this is water. Okay, and this is air. Right, so they need to transfer the energy. The molecule need to transfer the energy to another molecule. So of course for this one, it's much closer. So of course it takes shorter time. So means the speed will be higher because it will be faster. Because the arrangement of the molecule is much closer. But for this one, for gas, okay, it moves further away. So it takes time, okay, for the molecule to transfer the energy to the another molecule because they got a big space between them. Okay, and they say for the solid, of course solid is much higher. Okay, because the arrangement of molecule is very close to each other. So once you transfer the energy to this molecule, it will straight away transfer to this molecule and then to this one, then to this one. Okay, very fast. But for this one, it takes time. Okay, right? It needs to vibrate and then hit another molecule, transfer energy to that molecule, then goes to another molecule. Okay, vibrate, goes to another molecule, then transfer the energy. Okay, so after that, for this one take a longer time. Okay, they need to vibrate, all right? Then hit, okay, transfer the energy, then goes to another one, vibrate, okay? So that's why the speed of sound in water is very high if you compare with the air because the arrangement of the molecule. Okay, this one is actually to scan a fetus, okay, in the mother's womb. So what is the function here? So of course there should be a transmitter and also the detector, same like in the ship. There must be a transmitter to transmit the the ultrasonic wave. Okay, so here the ultrasonic wave will be transferred by the transmitter. Okay, so it says here what is the function of P is transmit the ultrasonic wave. What is the function of the detector? The R is actually to receive the reflected ultrasonic wave. It's the same as the ship also, the function. Okay, so how does the fetus is scanned until an image is formed? Okay, at first we have to a gel is sprayed onto the mother's abdomen. Okay, this one is to reduce the friction. Okay, reduce the friction force. Okay, and then after that, of course, the transmitter has to emit the ultrasonic wave. Okay, and then it will travel through the skin and of focus on the fetus. So the ultrasound will be reflect or bounce off, okay, by the bones and the tissue of the fetus, okay, and will be received by the receiver. Okay, so I explain again. So here the transmitter will emit the ultrasonic sound, so it will hit the fetus here, okay, by the bones, okay, and the tissue. Then it will reflected to the detector, okay. So the detector, the receiver will receive the reflected ultrasonic wave, okay, and then they will form an image, okay, based on the reflected wave, okay. So a computer analyze the signal to form an image. Okay, so for this one, don't worry, I will put all the notes here. Okay, later I will change to PDF and I will put in the group. So for those who cannot copy just now, okay, so you can copy later. Okay, so this is actually for bat, right? So it's same also. Okay, so bat also it emits the ultrasonic wave. Okay, so when it hit the obstacle, it will be reflected back. Okay, and the time of the emission and the reception of the reflected is detected. Okay, and after that, the longer the time, the further the obstacle. So this is the formula we use. Okay, the same as the ship. We just need to change a few words. Okay. So we already finished the reflection of wave. So wait for a moment. Anything you want to ask before I ask you? Anything you want to ask, teacher? Because after this, you will answer questions. No? So you are already clear about reflected wave? Alright, so let's try to answer for this one. Okay, we wait for teacher. Can delete my name. Okay. Farah. Which one? The caps.
Teacher, the one in caps.
Okay.
Thank you.
All right, welcome. Okay, so we wait for another 3. Okay. Right, so Farah, okay, close. Okay, so let's see the answer here. Right, so which diagram shows the correct pattern of the reflected water wave? So the first thing you have to know, the angle must be same. So if theta, the angle for the reflected angle also should be theta. So for C and D is wrong because this one is theta, this one is like alpha or something. Okay, so this one is theta, this one is beta. So means the angle is different. Right, so this one is wrong. All right, so it's whether A or B. Okay, so we see the wavelength. So the first thing we see the angle. All right, the angle of the incident and also angle of the reflection. The second one we see the wavelength. So the wavelength here, as you can see for this one, the wavelength is become higher, is increased, right? Before and after. So this one is lambda and this one is lambda. So you see there is a change of wavelength. So B is wrong, so the correct one answer is A. Alright, so let's see your answer. Okay, very good. Okay, let's see another one. Okay, so we already discussed the wavelength, the speed, the frequency, okay, is same, only the direction of propagation change. Alright, so all already answered. So some answer A, some answer B, some answer D. Alright, so let's check. So it says diagram shows the wavefront of a plane incident on the plane reflector. So which statement is correct about the reflected and incident wave? So this one is actually SPM 2005. Okay, questions. So the speed of the reflected wave is the same as the speed, okay, of the incident wave. Okay, so yes, the answer is A. Okay, so for this one, the answer is A. I noticed some of you answer B and some answer B. So remember I said when the wavelength is not changed, after and before must be same. Okay, so don't change. Okay, and D, some answer D. Okay, so I understand because you said maybe it's look like uh this is 90 degrees, right? So this one should be 45. This one also should be 45. No. Okay? No. What I said only the normal line should be right angle. But the incident angle, it depend on the direction of the propagation. So it doesn't matter. It doesn't need to be like this one is 45. This one is also 45. No. Okay? So it depend on the direction of the, they say this one is 20. So this one is also 20. So 20, 20 is 40. 40 is not the right angle. Okay. So remember the direction is always not the right angle. The right angle is actually for the normal line only. The normal line is a right angle. Okay. Right angle on the surface. Okay. From the surface. Not from the direction. Okay. So this one is wrong. Okay. Make sure you are clear. So number 3, the answer is A. A, D, okay? B is wrong. Okay. The next one.
Teacher, my slide now only came to the third one.
The third one.
Yeah, I'm still.
Don't change,
Our
is it?
slide is not changed.
Wait. Wait, don't answer. Your slide is not changing, is it?
All of us are in the third
Yes,
one.
teacher.
Oh, so okay, wait. I try again. Okay. Now is it changed?
No, teacher.
Still same.
Still same.
Still same.
Oh, why? Wait. Let me check. How about now?
Teacher,
Teacher, we out of the class.
class could change already.
Oh my god.
So now we have to use the
The new one. Yeah, the new one. I'm sorry. Oh my god. Okay. Oh, you already know the class code. You saw the on the screen, right? Should I give you the link again? I just give you the link. Sorry. Yeah. I'm using a new one. There's no image.
Yeah,
No image.
teacher, no image, only got your name.
Why ah? Okay, now got image.
Now
Yes,
got
teacher.
teacher.
Oh, okay. Thank goodness. Okay, you can try to answer. Remember for sound reflection wave speed, frequency, wavelength does not change, only direction of propagation. Okay, two more. What is propagation? Propagation means the direction of the reflected wave. Okay, so let's say just now. Okay, so all already answer. Okay, so which comparison is correct about the reflected sound wave and incident? So of course the speed. Okay, the speed is same. So the answer is B, boy. So I think all of you got answer B, right? Good. Okay, so we move on to the next one. So what's the formula that you should use for this one? So I give you. Maybe you still cannot remember. Yeah. Is it okay? So what is the S? D is actually the S, the therefore the seabed. Okay, so we still wait for Avinash, Krisha, Rindya, Lakshmi. Teacher, I hantar tadi. Oh. Then you tried to name, is it? Then who's another? Maybe one people they write two names. Okay, never mind. Okay, so for this one, we use S is equals to VT. So V, actually the speed 1,500. The time is 2. Okay, and you have to divide by 2 again. So you get 1,500 meter. So the answer should be C. So let's check your answer. Alright, C, 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 C. Nirupa, how do you got B? How do you get B for this one? Nirupa and Abi. Okay, the last one. This is the last one before we stop. Same formula. Sorry, teacher, I divide two. Why? The formula already divide by 2, right? Unless you use this formula, it's different. This one, yes. You have to divide by 2 later. But this one, you use this one. Okay. So we wait for another 7. Okay, so Avinash, Farah, and Lashmi. Lashmi, you already submit also. Who got 2 name here? No. Everyone got 1. Oh, okay. I think maybe your line code. Maybe you think you already submit. But it's just loading like that. Yeah. Before I forgot, we still on think on Friday. Okay, on Friday I will put the module. Okay, paper 1 and paper 2. Okay, so it quite thick, like 200 pages for each paper. So paper 1 262 and paper 2 I think 260 something. Okay,
400 plus pages actually.
yeah.
Oh my god.
Okay, that one's covered from chapter 1 until chapter 6. Okay, the exercise. So after we finish the syllabus, we just do the revision. Okay, after that, when school open, we just do experiment revision until the school close. Alright, so I will put this at the school at the canteen. Okay, on Friday. So once I already put, I will mention to you, and you can come to take whenever you want. Okay, you don't need to tell teacher. Okay, I think the guard there already, or we always be there, right? So you can just go to school anytime. Okay, so I will just close. S is equals to VT over 2. So V is 3 times 10 power of 8. Time is 4 times 10 power of negative 3. I in at my own, yeah, it's okay. I'm not sure actually when we use it. After we still got one more chapter, right? So it's okay. It's not, I'm not using it now. Okay, and this one is divided by 2. So your answer is 3 exponent 8 times 4 exponent negative 3. So you divide by 2. 3 exponent 8 times 4 exponent negative 3 divided by 2. So you got C. The answer is C. Yeah. Okay, very good. Nirupa, how you got B? Sorry. Are you divide by 2 again? Avinash? Lashmi? Oh. 1 divide by 2, then and after that you forgot to divide by 2. Okay, so make sure when you substitute the formula, you see, okay, after that you have to divide by 2 if you use this one. Okay, sorry, S is VT over 2. Alright, so I see you on next Monday. Okay, so take care, class. Alright.
Teacher, Saturday, right?
Saturday. Okay, I forgot to mention also. I will tell you when our next class is. Okay, for now, no, because I have a lot of work to do.
Okay.
Okay, so you
Teacher.
I will give you my homework. Okay, I know you missed my class, so as a replacement, I will give you a homework. Okay.
Teacher,
Yes.
Okay, teacher.
so Monday we do presentation, is it?
Yes, we do presentation. Still, have so many people didn't do the presentation yet, so we finish that one first. Okay.
Okay, teacher.
Okay. Bye bye everyone.
Bye,
Take
teacher.
care.
Bye, teacher.
Thank you,
Bye.
teacher.
Bye.
Okay, teacher. Bye, teacher.
Bye.